So, just to show you how to do this kind of thing in the calculator, you have to put it, I have to always tell you the x's and the p of x's. Right? That together is the complete list of data. So really what we've done today is we've come up with a formula for if they give me the data in a different way. It's organized differently than just a list. Then I want to make a formula that works better for that way they gave us the data. So there's going to be a couple more times when they give us the data in a different way, and we're going to make a formula that works for that way. Let that sink in. A student of mine pointed out that I say that a lot. That sometimes I don't actually let that happen. So I was like, oh, I'm sorry. All right, so I've got, if you want to do this in the calculator, especially if it's a longer list of data, I want L3 to be L1 times L2. I'm going to make it L1. That'll be my x times p of x. Now this L3, all these are middlemen, really. They each don't have any real physical meaning necessarily. They're sort of the contribution to the whole mean that each thing gives. So if the number is big and the probability is big, it's going to contribute more to the mean. And here that number is big, but the probability is small, so it's only going to contribute a little bit. So what I'm trying to tell you is if I ask you probability questions, where are the probabilities at? They're part of what I have to tell you, right? Those are the probabilities right there. Don't look at here if I ask you a probability question. Those aren't they're probabilities times x's. They're not just probabilities anymore. There's some other shit, right? And then L4, I can make x times xp of x. So I end up with x squared p of x. So I'll do L1 times L3. Any of that business. And then you can do like we've done before. Now let me show you. Let me see if you guys can have. I can do the list. I can go quits. I can go to list, and I can do math sum. Remember that? For L3, and then I can do it again for L4. Or you can just do calculate two variable statistics on, no Jeff, there you go, on L3 and L4. And it will tell me the sum of L3. And then look what it does for L4. It assumes that it's another set of data. So it just calls them y's. So are those the sums you guys got? Yes, ma'am?
Yeah. Before we were using the one variable stat, right? And now it's two.
Why is it two? I'm using two variable because I've got two columns of stuff, right?
Okay.
The L3 and the L4. That's the only reason I'm using two var stats, because then it'll tell me the sums. Now, please do not. This is just a shortcut kind of way to do this. Look at all the other stuff it tells me. Do I give a shit about any of that? No. I just wanted the sum of those two, right? So if you instead want to just do like you always did before, go to list, sum, L3, you get the 47 that I just got also, right? And if you do second enter, you can then go back and make it L4, and you get the other one I got. No worries. Just a few different ways to do it. So hopefully, most everybody I looked at had these numbers. So that's the sum of xp of x, and that is also known as the what? The mean. Kick ass. Now I think it's because the mean is done when I add it up that people think that this means something by itself, but it just don't mean shit by itself. It's just part of a formula. And this is the 2563 37. Now first off, real quick, why is this a valid probability distribution?
Because it's less than 1.
Yeah, each one is between 0 and 1. And? What else happens? The sum of p of x is 1. So those two things. If I ask you that question, dear God, don't lose points in this question. There are two things you must tell me. You must tell me those. Now actually check it. Trust me. Let me just tell you right now. I'm going to have a problem on the test where the sum of p of x will be 0.9999 or 1.0001. You with me? So if you just say sum equals 1, I'm going to know you didn't actually check it. That's just silly. You actually have to check it. And then you just say it's close enough to 1. It's not invalid because it doesn't equal 1. It's just close enough. It was probably rounded, right? So trust me, I will do that to you. It's going to be on the test. Yeah, approximately 1. I love it.
But it's always going to be like equal to 1, right?
The requirement is that it equals 1, and we'll be okay if it's really close to 1, because that just means it had to be rounded somewhere. We've seen that before in relative frequency distributions. Do they always add to 100%? No, because we might have rounded in there. So we're cool with it before, we better be cool with it now. Okay. Now here, let me ask you real quick, what's probably somebody who thinks they'll be 100 when they retire?
2%.
2%, yeah, 0.02. Alright, so these are the probabilities here again. Now there's two ways to answer this question. There will be at least 25. So that means 25 or more. So you can add all of these up. Right? And that's fine. But since these all add up to 1, you could do 1 minus this, and of course it will make this. Please tell me that math makes sense. If I have a bunch of numbers that add to 1, 1 minus any of them will equal the sum of the other ones. That's straight up basic math. Now again, if you don't get it, you just add all of them up. I don't care. That's fine. Add them all up. But either way you do it, you get 0.93, right? Or 93%. There it is. You do 1 minus 0.07, or you just add them all up and get 0.93. And here we already get the mean. What was the mean? 47.7. And here we know this. That is this number here. 2563.37 minus the mean squared. So minus 47.17 squared. So the variance comes out to be something. Oh shit, Jeff. If I would just type in the right number, it would all work out.
338.
No, Jeff. 338.361? Okay. And that is the variance, because I haven't taken a square root yet. So after you take a square root, you get what? Yeah, I get 18.3946 or just 5. Shebang. Yes?
How do you do the square root on the calculator?
Oh, so here's what I did. Let me clear this out. Let me do this again. All right.
I mean,
so
not
here's
square
this.
root, I'm sorry, the power.
Oh, okay. If I just have to square something, the beautiful thing is there's a square button. Right there.
X2.
Square. Now, if I had to do like something to the third power, your to the button's right here. There's your to the button right there, the little caret. I call that the to the button. So if I want 7 to the third, I would type 7 to the third. See the little caret? 7 to the third. I like it. Okay. Oh, now here. Those of you who have survived to this point, let me show you the shortcut to check your work. This is the work I must see. This is the work I must see. Here's a shortcut to check your work. You ready? Help me out here. How many? Now I probably really messed you guys up by showing you that shortcut with the 2 bar stats. How many variables are there in this problem, really? Not values, variables. How many questions did I ask these people?
1.
1. So there's 1 variable, right? The variable is the question, and the data is the answers to that. It's like the values of the variable. There's 1 variable. Where are the values of the variables, though? Not just L1. So I want to do 1 bar stacks, but I want to do it on L1, L2. Together as a package, they're the data. So that's exactly, to do this real quick in the calculator, I do stats, calc, 1 bar stacks. We've all done that before, so this is nothing new. But now I'm going to do 1 bar stacks on L1, L2. And let's see if we see anything that looks familiar. That's all right. I appreciate it. Ooh, Jeff, that's amazing.
I do the comma and it puts J.
Oh, you got, all right. You got it. So you do L1, and then the frequency list would be L2. That's my bad. So you got the newer, yeah, you got the newer, the one that actually has those 3 questions that asks you, the frequency list. is L2. Your data is L1, the frequency list is L2. That's sort of like relative frequency histogram kind of stuff. You see what I'm saying? So that's my bad. I forgot that. The newer systems, they ask you those 3 questions.
Charlie, she's a local.
What's this one? What?
What the subject?
Oh, here we go. Okay. So does everybody, you don't have to know how to do this. It's just a way to check your work. This is nowhere near good enough to say, I'll push these buttons and got this. I got to see this. Now this problem should sound very familiar, right? Put the mean in the middle. Go one step down. So if I subtract 18.395, who? You have no idea. Okay. Yeah, 28.775. If I just subtract 1 standard deviation. If I go up 1 standard deviation, add 18.395. That means 65.565. Is that right?
Yeah.
All right, Jeff. Doing math. Look at you. All right. So now that's like my net. We've done this before. There's a difference here, though. What numbers do I catch that's actually in the data? Do I catch the 21-year-olds? 25s? 40s? Yes, I catch all the 40s. 60s? Yes, I catch all the 60s. 65s? Yes, I catch all the 65s. 100s? No, those poor kids, they might be right, actually, shit. By the time they get to that age, we might be living them long. So, the thing is, it's not 3 divided by 6. It's not half the data, because all the 40s are 25% of the data. All the 60s are 16% of the data. All the 65s are 29% of the data. So then I just add those percentages up. I don't have to calculate the percentage. I just have to add the percentages up. I already know what percentage each one of these is. So 0.25 plus, what would this be? 0.45, so 0.7. That's right. So if I'm wrong, it's just 3, 4, 5, yes, 0.7. You guys get 70%? Okay, alright. And then finally, how many total kids are there in the survey? 200 kids. Tell you at the very beginning. And what percentage think they'll retire before age 50? No, before age 50 it was 40 or 25 or 21. Or means add.
So, yes, we'll say take all those and subtract.
No, just do 40, 25, 46, 53. 53% of 200. Yeah, so do 53% of 200. So 0.53 times 200 equals 106. 106 kids believe they'll retire before age 50. They are poor kids. They think they'll make another Facebook. God, we don't need the Facebook we have. Alright. I think that's enough. So don't forget, next time, the very first thing is the double quiz. And then we'll do a little bit more out of chapter 5. I'll put them on the, I forgot. That's part of what I was supposed to do today. But I just put them on the quiz. No worries. Yeah.
And then right after you went on, right after this, I think I put it really nice.
Did you get this here?
Yeah.
Good. It's the same thing we had to do before.
Yeah.
Oh, somebody at my... Yes, cool.
What's the difference between
Thank you.
when you were checking the L1 and L2 for the one variance versus L3 and L4 for the second variance?
The only reason I did that is because when I do 2-bar stats, it's able to tell me 2 sums. That sum and that sum, right? Now, of course, I think you've got different stuff in there, right? Or is this the stuff from here? That was weird. Why did it tell me weird shit? 2-bar stats. Oh, I did L1 and L2. That's smart, Jeff. So if I do 2-bar stats on L3 and L4, the only reason I did that is because it tells me the sum. Here's the sums. All these other numbers I don't care about.
The sum of...
The sum of L3 and the sum of L4, right?
Oh, the sums, okay.
Yeah.
Got it.
Instead of going in and doing stat, you get list, math, sum, L3.
So you're just, for that
But you
second,
don't
the
know.
two variable, that, you're just checking these two?
Yes.
The sum, okay.
Yes.
Got it. And then for the other one, you're checking the standard deviation and all that stuff.
Yeah, because there really is just one variable. I just use the two var stats because it's a shortcut to get those sums. That's it.
Oh, okay.
I'm not saying there's two variables on there anyway.
Yeah.
Because there's just one
Right.
question, just one variable.
Okay. Got
It was just a quick math
Yeah,
thing
because I
to do.
noticed it did X and Y sum versus. like-
Yeah, because it'll call, if I say two var stats, it'll think, oh, there's one variable, I call it X.
Okay.
And the other list, I'll call it Y.
Yeah, because they
So the
just-
calculator is kind of smart in that respect, just kind of
Okay.
nice, yeah.
Do I need to like a note from you that I can extend to my text, or do I? Because I feel like
I just need to email him when I get back to my office, so
want me to write you a note?
if you want to walk with me so I can do it right when we get there, of
course.
that would be a good idea.
Will do.
That's what I would
You want me to
do.
go drop these off?
Where?
Where did you get them?
From my office. I was like, where are you taking my stuff?